Good
Hi, Sammy. Morning, how are you?
Good, good. How are you? Morning, David. Let's give a couple of more minutes. While we are waiting, David, John, do we have any opens?
Sorry, what was that, Sammy?
While we are waiting for others to join, do we have any opens?
Not from my side.
I don't either. Yeah. So I just realized I didn't have a reminder on this. I have to go add my reminders, calendar reminders.
Yeah, I think I recall whenever we send out, it used to put a calendar notice, but nowadays I don't see that it's happening. Maybe there's some settings need to do.
Yeah. Whereabouts are you based, Sammy?
I'm based in Portland, Oregon.
Nice. Been a long time since I've been there. Based outside of London and Guildford, so yeah.
Oh, you've been there? Okay. Oh, you
Yeah.
probably came here for the sustainability summit.
Yeah, I've been there for that, and also, well, you probably know there's quite a lot of big companies around Portland, AWS, so
Right.
AWS, Microsoft in Richmond, yeah, lots more. So yeah.
Right.
Okay, so Portland seems to be the is it still CTAC? They're sort of traveling around from there. So yeah.
Okay. Okay. Cool. I don't know whether you guys know. I'm not going to review. I think Red Face DMTF released a new latest schemas. I went and downloaded the whole set. So probably we'll look after today's discussion, maybe next meeting, the schemas.
Yeah.
Originally, I was targeting to get the white papers done. No, it was crazy. I was able to get it done. But I thought like we'll have a discussion on what we need from the systems and rack. As part of the white paper, also we will be kind of saying like, these are the things needed. So I put a couple of just slides for us to get the discussion started there.
That'd be good.
So basically what I'm kind of looking is when we are talking about metrics, right? Regardless of how the formulas and other things going to settle on final ones. What I was thinking is there is a lot of power related, right? We want to make sure we can able to get all the power related items that we can able to get it from the systems and rack, and also power losses related items, right? There may be complexity. I think that's what we want to kind of discuss here and kind of get some alignment. Hi, Eric. Good morning.
Good morning.
So I was just telling David and John, like I didn't had a chance to get the white paper done, so I will try to target for next week to get it done. So
Okay.
this week I thought like let's probably spend some time to determine what we need from the system. And also Redface DMTF released a new schema actually last week. They posted it here. It's 25th they released. So we can use the latest schemas for looking at what is available out of their system and other things. But before even going and looking at those details, I thought like for sustainability related items, right? What we need. Let us put some initial thoughts here. Then we will connect this what we are going to putting in IUE as well as what is available in schema, and finally we will look at from the schemas available, and we will make a kind of recommendation. These are things needed, additional things needed. Right? Mm-hmm. So first, when we are looking at the power, we can look at what is a max TDP at a rack level, system level, and device level, right? It's normally like device level gets aggregated to a system level, and system level gets aggregated to rack level. Again, we do need to, some of the power is going to be shared between multiple systems. Especially when we are kind of looking at something like this, right? The fans are shared, and if you are looking at the DC, we are also talked about. Yeah, you could have shared things here, shared things here. So regardless of that, right, we can probably put how the sharing going to be working as a part of the schema that need to be representing it. But let us first look what we need on a power device, right? Can we measure the input power and output power? My understanding is smart power supplies has that capability.
Yes, a smart PD does 100%. So yeah, it's yeah, you can get smart rack PDEs which can be mounted into multiple, which would then report directly back into that. So that's PDU, not PDE.
PDU, yeah.
Sorry.
Smart PDU provides input power and output power, and the loss can be determined. Right. What other options we have? Is this only at a power supply level, right?
So quick question I've got for you, Sammy. When you saying rack, are you talking about just a traditional rack, or are you also referencing anything more complicated like in-row or rear door or different cooling strat? Are we just talking literally here like a standard metal 2x1 half a ton like rack? Just to clarify that.
Yeah, so if you look at the way Redface is going to describe a rack, underneath it can be traditional rack or DC bus bar.
Yeah.
Or even you could have a immersion cooling. You can say that is a kind of rack concept, right?
Okay.
It's
Okay, fine.
it's a representation from the Redfish perspective. It is like a rack. Underneath the rack, you have systems.
Yeah, so you can, there are two different definitions, right? I mean, you can use the firmware definition. You can also use the OCP definition, right? The Open Rack V2.
Yeah.
Let me see whether I have a picture of the schemas. Yeah, let me. See whether they have a pictures in here to represent. I know it was in the presentations. This one does not have.
Yeah, the reason why I'm just asking this silly question is just because there's quite a lot of new legislation hitting the EU and the UK with heat reuse.
Right.
And the racks that we're looking at for operation design are starting to now to need to have a lot more liquid cooling. And I just want to check some of them smarter ones that are in the marketplace do have power as well. So it's just a checking what do we need to cover from that perspective. So that's what I'm just trying to understand. And that's principally because I'm coming at it from an MEP design an engineering level from that perspective. So hopefully that helps just to clarify that a little bit.
Yeah, I was trying to see whether I have a picture of a Redfish model that's easier for us to have a discussion here. And I accessing my drives, it looks like network is slow today.
Yeah, because also for some of the other racks, there's also power that goes into them, because if you take immersion tanks, they've got power.
Right.
Unfortunately,
So
it was once so simple, it's no longer simple.
Yeah, I think what we are kind of seeing here.
But that should be captured hopefully within the overall.
Yeah, it does. I don't know. I don't see it. I need to figure out and send you some marker. I believe one of this things had the pictures. Let me see whether the spec has it. No, that's how everything is text here. Let me find an offline version and send a note. It is available part of the DMT of definition.
Okay.
Yeah, I will take care myself to send a link for you. So I think the way it is, the model is you have a rack underneath. You have systems. Underneath systems, you have devices. Underneath devices, you could have every single details can be represented. And that is general Redfish schema. I probably need to locate where I have some pictures here. Okay, let us for the discussion now. Let's assume that model and regardless of that, right? However, that is generally modeled to kind of represent what is the tree underneath. What is the devices? It's a collection of devices. Every single thing is collection. The name you could use rack, or however you want a collection of compute systems, right? Underneath you have a collection of systems, collection of devices. Underneath the system you have devices, and again each device you can have a more representation on what you want to get out of it.
Yep.
So in either case, right? if you have a smart PDU, you could have input power and output power. You can able to determine the loss, right? Do you need anything more than that? So there's two things, right? We do need a max capability, and also you need to understand what you're currently consuming. That is, I'm calling active power. So if you know the max, especially the reason we are trying to say it's a max is, I believe, you look at some of our formulas there, we said like we need to comprehend max and divide it, right? I think even here, right? We are saying like sigma of all the max TDP and divided by each system's TDP. So you do need to have a max. That max probably come from the definition. I don't know whether the smart power supply has the capability to represent the max itself. Can we query, or is it only is it going to provide you the what is currently being input power and output power?
It only give you the input and output power currently for that device. So you'd have to then still take the overall load for the overall room that you're looking at, starting off with, and then break it down. So essentially, would you still have a switch gear in the room or an overall power allocation, which you can then take that from as well?
So we do need to have a max PDU that is statically defined, and I think that is okay. You are not going to. Only thing is, if you replace it, generally we replace with identical power supply, right? If you have a redundant power supply, people could swap the power supply while system is running, right?
Yes,
Yeah.
if you have an N+1, right?
Right.
Yeah.
I have a different question for you, Sammy. Are you pursuing here a way to determine the VR and I2C losses as well?
Yeah, we do need to account that. So DC losses need so Eric, your point is how are we accounting for the DC conversion loss?
Right. So if the devices can report their power, and you actually know how much DC power there is, you could try to back into it, but that might get pretty complicated, right? Similar to where John was going, right? If you know the total DC power supply and you add up all the devices, you could assume everything else is a DC to DC loss. But if you have any devices not reporting, that'll show up as losses, right?
Correct.
Yeah. So what we have for DC to DC, like can we also get a input power and output power, or is it a VRs or smart VRs?
We do have some smart VRs. I don't know where we are in requiring them, and I don't know. You can imagine the issue is, right? So when we ship 48-volt bus bars into a power distribution board, the PDB puts out 12 and 5, right? Modern devices outside of like the fans themselves don't take 12 and 5, right? So there's local VRs around every DIMM population, around every IC, right? But all our active devices have local VRs. I don't know that every last VR is going to be smart, right?
Right. You want to be the top level VR may be smart, but the local VRs just
the big ones will, right? Like VR15 for the CPU socket, the VRs associated with OEM sites. Those big instances probably could be smart, but we'd have to require that, right? In order for a scheme to work, we'd have to have a profile where that's not optional, that's required, right?
Right. So there's two things, right? If it local VRs going to fan, we can say it is anyway fan is accounting as a loss.
Right. Just the input power to that VR is considered a loss.
Loss. So it doesn't matter whether you measure at fan level or a VR level, right? As long as you can measure the input going to the VR.
Presumably the same would be true if you had direct to chip, and if there's any kind of.
Yeah, it's that I was just trying to work out with that heat exchanger, and that's the bit I was just thinking. If you've got a cold plate or a heat exchanger going through from a cold water system, would you be? Could you measure that?
If it's active, circulate the fluid, then that's equivalent to fan power, right?
Yeah.
Any impeller power is just like fan power.
Exactly.
And that's one of our issues with the organic fluids, right? Is that you're trading one for the other. They're high viscosity. It takes real work to move them.
Yeah. 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 So basically, you're looking at the flow rate going through, and are you still then utilizing a cooling tower at the back end of it, which you then need to measure as well? But is that going too far outside of it? So yeah, I don't know.
Yeah, I think we do have to think about that, right? That might be a slightly different conversation than this one, right? So we have, this DC to DC, and then John's kind of backing into another good one, right? If you have a X racks per CDU and the CDU burns power, you got to account for the CDU somewhere.
Yeah, and that's literally what I was just thinking of. Where do you account for that? I was like,
if it's an in-rack CDU, we absolutely are stuck, right? There are solutions with in-rack CDUs for DCLC, right?
Yeah, there are. Yeah, this is where.
And I guess we could say the bus bar, input power to the CDU that's in the rack is all losses from perspective of IUE.
Yeah, that would make sense. Do we need to just caveat? Obviously, depends on the solution that you're then deploying, because that will obviously change it. Considering if you've got D2C to traditional air to cassette to immerse, it's all going to be slightly different metrics. Don't know.
What?
Oh, pumps. You just want to pee is all. Pumps.
Yeah.
Yeah, or impellers or whatever you want to call it. Fluid fans.
It's a screw, isn't it? And I'm not meaning that in a rude way. It's a fluid screw, isn't it? Like a submarine.
That's right.
Yeah. But yeah, pumps is fine. I wouldn't start putting the word. Yeah, I know what I mean, but it's a case of people might take
motor,
that completely.
I can say just motor, doesn't matter.
Yeah. Yeah. I don't cause a diplomatic incident by using the word screw.
So any other things, say DC direct to chip, and do we have any cold plate does not have consume anything for circulation, right?
I think you may want to change your hierarchy here, right? Where you don't want direct to chip and CDUs underneath VRs.
Oh yeah, okay.
There you go.
That's better, yeah. The only other thing I would say is, do you want to include VR smart fans? Are we including water-based cooling or liquid-based cooling within the VR, or is that a different set, like direct to chip? because I'm just thinking that through, because obviously that's got a slightly different, because I know
Yeah.
we've designed a couple of sites with local resourcing utilizing water, and it does then reduce the PUE, doesn't reduce the site efficiency, but then also it is using cold water plate technology and heat exchangers to then drive down to the right temperatures again. So it's slightly different, that's all. Yeah, effectively, it's a bit more like the D2C, but not quite. Yeah.
Yeah, I think in this diagram, I think logically this is the right cartoon, right? What it doesn't show really is inside the server what all is on the loop, right?
Yeah, right. It's
if the loop's passive, we don't care, but if the loop has a power associated with it, we do care.
Yeah, I'm just trying to think if it does. I know from seeing them in the UK, the cold logic racks and the U system racks, some of those have got power for pumping that is utilized, but it's so minimal. But it's a case of yeah, I'm just trying to think it through.
Right. Well, and I think right now we could probably make things optional if we know them to be small, right? But we're like what Sammy's doing is trying to get a comprehensive schema that has a place for everything we might need, and then we'll go figure out how to get it all.
Yeah, I don't think we can count for everything. Yeah, sorry, apologies for that. I'm just thinking things through. Yeah.
Well, and that was why I was trying to think through the, if we want to back into DC to DC losses, how bad would that be, right? If we know, in just a 2-socket GP compute server, the 2-socket CPUs are probably 70 to 75% of the total DC load.
Yeah.
So if that set of VRs is smart, and then you've got the fans and you've got the DIMMs, if you got a modern smart NIC in there, you want the NIC for sure. Obviously, if you plugged in any accelerators, GPU cards or something, you need those too. But what's left is going to be pretty small, right? What's left is going to be, in terms of actual power dissipation, is going to be probably less than 5% of the total. So we have to think through what's our approach on any other incidental VRs that are low power. We could say VRs above some total capacity have to be smart, right? We don't really want to mandate smart VRs for 1 watt, right? Like the BMC subsystem, maybe 6 to 8 watts. It will have a VR, right? But
do we want to say something like a percentage of device power or something like that?
But it may be better to use an absolute scale on the VR capability, right? VRs bigger than X need to be smart, right? We'd have to think this through, because then we're inviting up to some amount of error, and we'd have to figure out what that is. Right, where basically any device smaller than what is instrumented is going to be counted as a loss. And then when we turn around and we try and mandate reduction in losses, if we go that direction, everything we put in that bucket that is as an actual required device makes it harder and harder to reduce the losses, right?
Or can we say that we could put a percentage, maybe, I don't know, 95% efficient, then doesn't matter whether you're totally smart or not?
Well, efficiency is not the issue, right? It's dissipation that's the issue. It's how much does it scale up to? Like, the CPU subsystem losses are massive, right? If you have 700 watts of CPUs and you do a 12 volt to whatever the input voltage is, 1.5 or 2 volts or something like that on the first stage, and then it's got a local dynamic voltage frequency scaling VR also cascaded, right? And if and now you're talking about hundreds of amps of current, right, out of the second stage. So the net losses into the CPU is staggeringly high, right? Shockingly high. Well over 15%, always, right?
My
And it
question
doesn't
is it
seem
linear or is it non-linear? That's why.
It's linear. It's linear, yeah.
Okay.
There aren't any quadratic elements to it that I'm aware of, right? But if you look at a 1,000-watt machine, or the active power of the modern servers we just launched are in the order of a kilowatt. The theoretical max power, the rated power, is well over a kilowatt. And like I say, 70-75% of that is the CPU, and you've got 15+% losses getting the power that the CPU actually needs, right? So you got 150 watts of losses,
which is a lot.
Which is a lot. Yeah, it's so I expect, and obviously we haven't even put in an IT side efficiency metric, but as soon as we do, right, there's going to be probably two fuses lit, right? One on the part of us here in OCP building systems and writing system specs, where we want to go stipulate what's acceptable and what's not acceptable in terms of losses, right? So, and that would go where you just went, Sammy. It says you have to use very high quality VRs, very high efficiency VRs, and B, you have to design those things so that they're in the active ranges where their max efficiency is, which hasn't always been the case, right? So we'll go do that and design and specify what kinds of VRs you have to use, and then on the regulation side, if we go make this visible, some clever guy's gonna say, okay, well it's X today, it needs to be less than X tomorrow.
Yeah.
Right. But I think my question is, if it is not smart VR, can we put a static number?
Just to make a linear assumption. I see what you're heading. We could do a first order estimate based on, but again, yeah, I guess you could. You just have to make sure, if it's smart, you will inquire as to what categories is a platinum or gold or whatever the rating is on the VR. Smart VRs will report their efficiency somehow. Dumb VRs won't. So the dumb VRs that are the problem, we would have to make an assumption about their efficiency and then make the linear assumption based on that.
So we could basically say that if you don't have smart VR, that schema need to provide the factor.
Yeah.
Right. If you have smart VR, you can measure it. If you don't have smart VR, we could potentially factor in a factor.
This is a way to get a solution built either way, right? Where there's a default factor we put in there, and if you know better, then you update it. And if you don't, then you don't.
Right. Okay.
Yeah, it's a good approach. But we would still need to, still have to go show the math, right? So what's our approach to get the value to put in associated with the loss factor? Because we're not measuring the input power either, right? So we'd have to calculate what we think the input power is and then apply the loss factor. It's a little bit of a house of cards, but like I said, I think as long as we're talking about only like 5% of the total power, the error is not going to be material, I think.
Right.
That would be our argument, right? In terms of, we don't want to overcomplicate this any more than we need to, and we don't want to add more expense than is rational.
That's true. So they could potentially it's not perfect, but at least it comes a very close approximation, right? So
right, because you can imagine, maybe we're off 5 or 10% on our assumption for what the efficiency of the VR is, right? But if this VR is 2% of the total power and we're 10% off in our efficiency assumption, we're talking about a 0.2% error in what we added up, right? It's not a big deal, right?
So, I mean, it's almost like we need to sort of at a later stage determine the fault tolerance that we can work with, or what that looks like.
The precision, the accuracy. What's our claim? That's what we're after.
Yeah, so where they haven't got smart capabilities is what is default tolerance that should be allowable that we could define here really. So but again, we probably need a bit more data before we put that in here as a.
Yeah, it's associated with that fourth bullet, right, where we stipulate for all the VRs that are in the path of DC power consumption, anything bigger than X needs to be smart, and the rationale for that is to contain the absolute error, right, to enforce a precision.
I'd almost say we need to measure it as a so you do like a sliding scale factor going upwards as the servers increase or the power increases depending on what's going into it. So that might then, obviously, if you can't have the same tolerance for a 1 kilowatt server as you would have for a 300 watt server, because obviously that's quite a lot of costings going out the window for a lot more power being lost somewhere. So yeah.
Right.
Yeah, cool. Okay.
So
yeah, and that's been our issue with some of the more simple proposals that predated this effort, right? There was a measure the idle power and just call that. They had all of the losses balled into that. The problem being, of course, the losses scale with active power, and if you left the idle power alone, you don't account for it.
Yeah,
and
I mean, it's not.
As we talked through that turns out to be quite a bit of power. So we don't want an approach quite that simple.
Yeah, I'm very much aware of some of the new servers that are coming through to the marketplace, which is something like 2.5, 5 kilowatts, or so. I saw one the other day for 7.5 kilowatts.
That's right.
And it's a case of
See the data sheet for the DGX box from NVIDIA.
Yes, funny enough, I was tempted to say it then, but I was like conscious of Sammy and everything else from Inter, and I was like, do I want to say that out loud? But yes, I think I've been reading up on that spec sheet.
That's right. The 15 kilowatt rack can take 2 of them.
Yeah.
So here it seems like we could do a rack and system level, but do we really need a device level power?
Well, like I say, it depends on how we get to your VR requirement, right?
Right.
If you have device power, then the input power associated with the VR, the max input power associated with the VR, and that tells you whether that VR needs to be smart or
not.
And if in effect, most colo operators and most hyperscalers would always have a default for how much power is going through to the rack anyway, from their overall infrastructure setup. So that should be known, and then when they do the breakdown per U, they will then normally have an understanding of what that power breakdown should be then within the rack for the heat management and for the thermal management of that for the hot and cold oil. And that's very much from a traditional standpoint. So they should have that understanding, because they'll be looking to then back charge that. It depends what operation is, but if you say it's a hyperscaler, they will have that understanding for a thermal load capacity 100%. So they then manage those hot and cold oils correctly, because that's where the heat's going to be coming through from the device power. So that's the key thing from my viewing of this one.
Yeah, I think the reason I was kind of going for the device power, right? Now let us say you have VRs and you're kind of saying like, hey, I'm having total loss, right? At the end of the day, the loss is the one we are trying to account, right?
Yeah.
Yep.
Now, if you want to go and say this particular system is having more loss, and you have to kind of root cause the problems, you need to go to the next level, right? Hey, this particular IO device is having more loss, and you need to figure out what to do with it, right?
Yeah,
that's right. Yeah, we want to make it possible to look for anomalies, right?
Right. Again, given you could have power could be shared between multiple IO devices, so you could we need to provide the power sharing boundary, right? This need to be represented at a rack level, system level, as well as device level, right?
Yeah, rack, system, and unfortunately U level for some of it as well. So yeah.
Right. So this is going to be the mechanism to kind of say like who and all sharing what, right? Then once we say who and all sharing it, all the power related details, when we put together, then it kind of come together, right?
Mm.
So I would also kind of say need to account for do we need to break anything further than that? I think that's good enough, right?
That should cover everything, I think.
Right. For the ideal power, it's kind of collection of the power that we are getting it, right?
Mm-hmm.
Is there anything that we want to define the ideal power? Like we want something reportable by the schema, right? If I query the schema from Redbase, it should say for this particular system, what is the ideal power? And I'm trying to see what is the boundaries we want to this guy, like, let us say, if I'm saying system level, what it need to collect to look in order to say the ideal power, right?
Yeah, and now we're going to get into the. Are we going to slide into a definition of idle, or are we just going to talk about a condition under which we are trying to calculate?
Yeah, I was literally just,
Firm up on it, right?
I was just thinking of that in the background.
Because the if we are informed right in the management chain here, we're not going to actually know whether the system's idle or not. Someone would have to tell us, right?
Yeah, you'd need to have effectively the way it would work from a data center and from a DC operator perspective, that they would know when it was idle and when it wouldn't be. Normally from the BMS or the DCEM system in the background for when it's performing and carrying out multiple operations, because there'd be a big spike that they would normally see. But normally, depending, well, yeah, I don't know. Depends on the operation, doesn't it? It depends on what it's.
Yeah,
Challenge.
My key question here, I think, Sammy, is if we are capable of reporting the power, do we need to know if the power reporting is an idle power or not?
Yes, part
So-
of this calculation, right? I think what I'm kind of looking is power is not a thing, but we need to reduce the ideal losses.
Right, no, agreed. We want to make it possible to, again, kind of quantify what is the idle power so that it can then be optimized, right?
Correct.
And we're not obviously in the business of stipulating the optimization, but we want to make it, right now you can't tell what the idle power is. If you're very clever and you go through extra manual work, you can figure it out. And people are doing that because it's interesting enough to do. But I think the way that it would work, right, is, we instrument all the hardware and we give you this firmware capability to go get at it all through an API. And it's up to the guy orchestrating the infrastructure to say, okay, I've provisioned all the platform software, but I haven't deployed any work yet. Give me the power. That's the idle power, right? And when I start deploying work, heading towards average load or peak load, I can figure out the power associated with those two. But if you're in the infrastructure, providing all these elements that we just talked through that add up to the power, you don't know if that power is an idle power or not. You could guess, right, based on where you are on the absolute scale relative to your rating, but you don't really know.
No, there's no way to know unless effectively you're set within that organization, you know when they're running or what they're processing in the background within their data sets and how they're looking to do it. Because you might have an archive that kicks off at midnight and goes through to 6 o'clock in the morning where everything goes absolute full health and leather. And then you don't know.
Right. Yeah. So we just don't, and where the reason I'm coming at it this way is it may be more complexity than is warranted, right? It's not clear to me why they would need to tell the instrumentation what state it's in. right?
Well, the only reason they would need to know would be from a data center operator's perspective, is so that they can account to make sure if they are having to manage their power and they are having to cope with any clawback mechanisms, that they have the required power for any uptime or any not uptime, any peaks for those windows, to make sure that they don't have any losses occurring. And that's not something we see in the industry at the moment, but it's something that is being talked about from government legislation, where they are looking, with all the powers not being optimized, can they effectively claw it back? I don't know how they will look to do that in theory, but it's something just to have on our radar. But is this going to affect this here? Probably not, but it's just a thing just to consider. So from my, do we want to protect the data centers and the hyperscalers and everyone else in the background who's performing this, or are we looking to go with the government legislation that might dictate it slightly differently? That's a question.
Yeah, I think we're trying to exert some influence so they meet in a rational space, right?
Yeah.
Because otherwise, you're right, and there's going to be some ill-informed collision, right? But I was really coming at it. Obviously, the infrastructure operator needs to know, right? Again, we're trying to enable anomaly detection, like with the case that I talked through with a kilowatt class system. We know what range the idle power should be in, right?
Yeah.
As designers, we right now the infrastructure is not that smart, but if you could query the power and you're expecting it to be, you know the provision power, you know the peak active power, you can build a record over time of what the average power normally is, so that you can detect an abnormal value. You also can modify the state of the system, like you're doing a rolling software update or whatever you're doing. And you take all the work, take all those systems out of the load balancing pool, wait for all the jobs to finish. Now the system is idle, in air quotes. You could query the power then, and you'd know what the idle power was. And if it was out of the range that you expect, you could detect that. But that's all on the control plane, right? This implementation plane where we are inside the rack, do we need to know what state they're looking for? Are we going to interact with them in determining what's good and bad?
It depends on the commercial model a little bit here, because some data centers might penalize them for it, and they will then charge them extra for it. So they want to know the idle's power. So if they do exceed it at times when not agreed.
Yeah, I'm just trying to figure out. Yeah, I agree with that, right? So it needs to be possible to go figure out what the idle power is. The thing I'm struggling with is I don't know that any of the infrastructure needs to know its idle power.
It would, the site would need to know for the rack level, at a rack level.
That's an agent outside the rack, though, right?
Yeah, but that's because that'd be out. But within the rack itself, doesn't matter, does it?
I don't think so. And the reason I poke at it is because it would be complicated. It would add complexity here, right? Because if you're any part of this infrastructure, the power supply, the AC to DC hardware, or the DC to DC hardware, or a BMC in one of the rack units, or a chassis manager in a multi unit chassis, you don't know how you're configured. I mean, you could go query all that and figure it out, but it's a bunch of complexity to go figure out what your idle power should be. I'm not sure any of that complexity belongs in this system, right?
Yeah.
And if you put the complexity outside of the rack where I think it belongs, just bear with me for a minute, we may change our mind, but then whoever measures what the idle power is would have to turn around and tell you, and then you'd have to remember. And to the point that Sammy was on earlier, then you could hot swap something or add devices. And if you don't remember to update this value, now it's wrong, right? I don't know if we even want a place for someone to tell us what our idle power is, because we don't really need to know in this subsystem.
No, but I'm just thinking of the opposite, though. So imagine you're running something at an idle power level for a rack, and you then have got a couple of you spare. You don't realize the fact that it's running at an idle level at that moment, or that rack is running idle, but is then going to have a key performance on it's then going to uptick. But effectively, you've then exceeded the power for that rack infrastructure, because when it then does suddenly run, you've overloaded it. So you then get a power balance issue. So I'm just trying to play a bit of devil's advocate a little bit, because I'm just trying to think it through, but I'm just trying to make sure we're not missing something as well.
Right. Well, if you want to, put in the green light for where to plug in the next thing, the system that turns on that green light has to know what the rated power is of everything in the rack and what the peak active power is of everything in the rack, right?
Yeah.
And if you're out of peak active power, you don't turn on any lights in that rack, right?
Yeah.
Again, I think that's an agent outside of the rack's problem. It's not the rack's problem.
No, it's not the rack's problem until basically it fries it, because there's not enough power. Or it struggles in the background to meet its no, okay. Okay.
So I think we are trying to enable a usage flow, right, Sammy, where the idle power can be measured.
Right. I think
So it
method
is a
probably
metric that is needed by somebody, but I don't think
somebody has to compute even a static number. If I put right now after we having a discussion here, right? I see like maybe static number depending on if you do a hot plug, right? The number is still going to be not right?
Sorry, Sammy, you need the idle power. Sorry, I have only been partially involved in the past few minutes, but now I'm here. So you need the idle power for your IUE, correct?
Correct.
So the problem with static number is that, with drives and all currently, you do use an understanding of the static number, but then the problem is with the accuracy. It's more like picking up a spec sheet.
Yeah, I think that's we like the dynamic one. I believe the discussion what we are having is, I mean, like VRs, right? We were discussing, right? If we don't have anything, at least you have to start with static so that we get a system at least putting the number so that we can calculate. But dynamic is the one we want to probably recommend, where even dynamic, what I mean is only you can compute during system is running, right? You're not going to, whenever you query, you're not going to force the system to go to idle and measure it, right?
Correct.
So it has to be.
You can measure it when, you're first basically docking your system.
Correct. So then you keep it there, and then you still need to account for hot plug, right? If you drives gets added or removed, or I don't know, other things getting added and removed, you need to account for it, right?
Drives getting removed, I understand. Drives getting added are probably is probably not happening, right? The system is first probably docked with the capacity it's meant to take and work. I can understand, some components go down and some drives might not be either functioning or removed afterwards. So what the number you will be left with will be the higher end idle power.
Yeah, I think we have to be, again, there's a issue here between absolute correctness and practicality, right? We are becoming very intentionally, right, more modular and interoperable, right, where you can swap out something and keep everything else the same. Now, the thing you swap in may not be identical, right? So if you like pulled the time cards from all your networking gear and updated the time cards, and the new time cards have 20% higher power,
Okay.
that would work, but now all the numbers that you remember from your original configuration are incorrect.
So
this is the problem with static or one time at provisioning, right?
Right.
And since OCP stuff is so modular, I don't think we want to turn a blind eye to that. It can change while deployed scenario.
Yeah.
But I think we're kind of down a bunny trail here.
I do feel like, okay, I don't know how much is, the change in the example that you gave, but I would not, like, I would think it is okay to leave that as a power margin kind of thing. Because yeah, of course, this is right. The system is not going to be put into idle again to measure this power. That's not going to happen. So there is no other, proper way for it to actually keep measuring repeatedly what is the idle power.
Yeah, the only challenge I've got is I completely agree with anyone here, but I'm just thinking with the new servers that we're seeing coming through in the high power, there might be quite a big significant drop between the idle and the dynamic, and it's how we just capture that. Again, I don't know if we're going down the rabbit hole a little bit, and I completely agree. But yeah, I mean, I think as long as we've captured it as what you were just saying then, between the two workloads, we've got an understanding of it. I think that should be good enough. But it's just making sure if there is any challenges to that, we understand what those metrics are. Because I'm just thinking with the new, more powerful servers coming through, is that going to see a greater disjoint than what we historically would have had, or is it still going to be, or is it still going to be the same percentages? I don't know. It's just a question.
Yeah, I think here even when we say no workloads deployed, right? We do need to have a little more definition of what is that, how the system can measure it, right? Well, for example, BMC need to report. Let us say the BMC need to figure out how they can say like CPU is not loaded, maybe on an account or I don't know, memory transaction or how many transactions going on or something like that, no transaction or something like that, right? Similarly, like IO devices, it's no IO traffic, right? Something like that, right?
Yeah, I think, yeah, we this is one of those challenges where we kind of know what we mean, but trying to specify it in absolute terms is going to be very challenging. So I go back to my high level question. I think we need to make it possible for the operator, the agent outside of the rack, to determine what the idle power is. It's not clear to me that the rack infrastructure needs to participate in any way in detecting or defining what idle means.
Yeah, but how the rack guys will know unless system reports, right?
The orchestrator would, the control plane would have to tell them, right, give me a power measurement. And if they categorize that as an idle power measurement, that's up to them. The rack doesn't have to report this measurement as an idle measurement.
Okay.
No, but like based on what would they categorize it as idle or not idle?
Just like you said, Shruti, they have state that we do not have, right? They know if they just racked this system and booted it and provisioned all the software onto it and have it put it in the load balancing pool and there's no work in air quotes on it or not. The orchestrator knows that, nobody else does. And it's not clear they need to tell the system that it's idle.
Okay,
right? So you could put the rack into that state from outside of the rack. You could measure its power and say this is the idle power and put that somewhere. Nothing inside the rack needs to know that that happened.
Yeah, that's true. That is true. They know initially when they are talking that at this point it is idle.
And in fact, if they're trying to do power tuning or look for anomalies, which is probably what they're doing, right? I mean, this is what Method does already, right? They said when they update their platform software, right, the cloud platform itself, part of approving the release is making sure that you didn't materially impact the idle power of the rack.
Yeah.
And one of the reasons they were after this is because they found out that they could drastically impact the idle power of the rack. And they decided that was a bad software release and rejected it, right? And they want to be able to do that. But so in order to do that, the rack has to be able to report the power, and the orchestrator needs to know at what states am I supposed to go measure the power and what's a good and bad value, right? But the rack itself doesn't really need to know if the measurement you're taking is an idle power measurement or not. You just give them a measurement when they ask for one.
Yeah, no, I agree, very clear. based on
And
that experience.
how do you account the hot plug or shared things, shared
Oh,
memory?
it's easy, right? If you send a hot plug event and there's an infrastructure inventory change, they go back and do it again, right? If they want a new idle power, they can get one. If they don't make you idle, you can't give them one.
Yeah, correct. That's
I
what.
think we would have to leave that. Yeah, I mean, it's going to be hard saying that one component like a drive is removed and you put it in idle again, and because that doesn't happen.
Yeah.
So it's not actually going to probably measure it again. We might, I don't know, if we want to think about putting, a margin, like a error margin, saying that as hot swap happens, maybe the actual power will sit within this margin, something like that.
Right, but if you
Okay.
think about your Olympus system, Jersey, right? If I decided I was going to make another GP compute server into a GPU head node, and what I swapped in was the OAM tray, right? I just changed the power by 3 kilowatts, right?
So we are top of
Cool.
our. I think let us
Okay.
start thinking further. I believe this really needs some more work to. How do we operationalize it, right? Orchestration one way we can say like, yeah, we have a method available, but we still probably need to think through further to kind of close the other areas.
Yeah.
So I will next week. I want to first get the white paper out for you guys for review. I will send it out before the meeting, and also kind of this is a your paper white paper is going to be more of a working version where I will start putting all these kind of touch points there, but we will, as part of when we discuss further, then we will fine tune in the wording over there.
Okay. Yeah, and I think we do want this in the motivations, right?
Right.
We want to make it possible to measure idle power and look for anomalies or do tuning of idle power.
Right.
What role we play in that, we'll have to get back to.
Yeah, it would then affect. I know there's some solutions looking at now from my side is like energy harmonics to help in balancing of the load, which will then come down to that level as well. To optimization. Yeah, no, cool. Just a quick one. I know we've gone over the hour, but I'm on PTO next week. It's my wife's birthday. She will kill me if I don't take some time off. So I won't probably be on some of the call tomorrow, next time, but I will be back on when I can be afterwards. So yes.
Very good. Thank you.
All right, cheers. Congrats.
I'm not sure about congrats. Just a case of not getting killed by the wife. It's more.
Yeah, I think you're playing your cards well. So.
Just time. Okay.
Yeah.
Okay, team. We'll see you guys next week.
Thanks, everyone.
Bye.
Thank you.